All right, ladies and gentlemen, 2.5. I'm just going to hit a couple of the unique ones that are really kind of tricky to get set up. I'm going to set them up for you, but I'm going to leave the calculating and the solving actually to you so that you can see how you're plugging these in and solving for these. So from the side A, 2.5a, we're going to be taking a look at 3, 4, and 6. Just a couple of these kind of unique, weird ones to make sure you're feeling okay on these. These have kind of stepped up in difficulty, obviously, the second time through. So we're really going to make sure we're understanding what's going on here. So let's look at 3. Light travels at this ridiculous amount of miles per second. That's great, but we haven't had a question yet. So this tells me that this might be information that I'm going to need to know to solve this. Here's a question. How long is a light year in meters? So I'm trying to get to meters in the end here. And I want to know how long in meters over the course of 1 year. Well, years measures time, meters measures length, and our key to getting between those is here. If I said 1 Mississippi in 1 second, you would tell me that that light is going to travel 186,000 miles. And that is information that we're going to need to know. All right, well, we're in years. We're going to have to get to seconds to be able to change into miles. And rough. 1 year is equal to 365.25. Got to remember your leap year days. Years cancel. We're into days. We know 1 day is equal to 24 hours. We know that in 1 hour there are 60 minutes. And every 1 minute is 60 seconds. Those ones we're all pretty familiar with. Just a matter of setting it up to get those units to cancel. Now that we're in seconds, we can use this little conversion factor that they gave us. They told us that in 1 second, light's going to travel 186,000 miles. Now we're out of time and into distance. Now we need to get from miles to meters. Well, up above, they told us that this many miles, this many feet. And if we get to feet and then to inches, we can get to centimeters, centimeters, back down to meters. All right, well, 1 mile is equal to 5,280 feet. 1 foot is 12 inches. 1 inch is 2.54 centimeters. I'm running out of space. And our last step here, sorry guys, so we go up here right at the tail end because we got to get from centimeters to meters. We know there are 100 centimeters in every 1 meter. Sorry, that should be up there right at the end. Yep. Here's your setup for problem 3. I know it looks like a lot, but imagine if we work this out one step at a time, it would be a 1, 2, 3, 4, 5, 6, 7, 8, 9-step problem. Now we can calculate the top, calculate the bottom, and divide and get our answer. Cool, take a look at number 4. The pressure exerted by the atmosphere is this many pounds per square inch, square inch being area. What is the pressure in kilograms per centimeter squared? Ooh, we've got a double conversion factor. It is 2 for 1 deal here in chemistry. So start with your given, 14.70 pounds per square inch. All I did was pull this inches squared down to the bottom. This is still pounds per square inch. I've just kind of rewritten it down here to make it a little easier to see where we're going. We're trying to get to kilograms per centimeters squared. Doesn't matter where we start. We can start on the top. We can start on the bottom. Let's start on the top. We're going to ignore these bottoms right now. We're just going to worry about getting from pounds to kilograms. Well, up at the top, do we know anything about pounds? We do. This many pounds is that many grams. All right. That's our next step. We know that 1 pound is equal to 453.59 grams. Pounds cancel. We're ignoring the bottom for now. Getting into grams. Well, King Henry died by drinking chocolate milk. There are 1,000 grams for every 1 kilogram. Grams cancel. So right now, tops are taking care of themselves. We've gotten into kilograms. Now we're going to ignore the tops. We're actually going to ignore all this work that we've already done. And we're just going to worry about the bottoms. Inches to centimeters. Now we know inches to centimeters here, but the problem is we're squared. Now area, if you're finding the area of a paper, it's length times width. So inches squared is really inches times inches, and centimeters cubed is centimeters times centimeters. So if we set up that conversion factor that we got from up above, we have inches on the bottom right now. So in our next step, doesn't matter where it is, in our next step, 1 inch on top, so that our inches cancel, they're across from each other, is equal to 2.54 centimeters. Now, this is 1 inch. going to cancel one of these. Now, if we stop right now, our units would be inches, centimeters, which is not okay. To get rid of the second one, we do it again. This inch cancels the other inch. Now, if we check our units, on top we've got kilograms. On bottom, we have centimeters times centimeters, which is centimeters squared. That's how we set up number 4. Our units are there, so all we got to do is solve. Multiply the tops, multiply the bottoms, and divide. Number 6. Number 6, our given, we've got 22,300 kilograms of jet fuel over 1. We want to determine that in liters. All right, well, we know that this many grams per milliliter. Oh, all right. Well, if we get to grams, we can get to milliliters, milliliters to liters. So we're going to use this as a conversion factor. We're in kilograms. 1 kilo is 1,000 grams. 0.803 grams per every milliliter per every 1 milliliter. In the case of jet fuel, grams cancel. We're in milliliters. King Henry died by drinking chocolate milk. 1,000 millis for every 1 liter. I want to show you how we could use density as a conversion factor on this particular problem. Only unit we have left is the unit we're looking for, liters. Multiply the top, multiply the bottom, and divide. Those ones I wanted to get on 2.5, good luck on the rest.